solve this equation, I'm going to need to sort out some double angle formulae. So cos 2x is cos squared x minus sine squared x, identical to, in fact. So a good idea. I don't really want to get a sine squared in the equation. What I can do is replace that by 1 minus cos squared. And it's really good. If you can go straight to this, brilliant. But I always sort of start from here and then derive it. So 2 cos squared x minus 1. And therefore, we are aiming to solve cos x plus 2 cos squared x minus 1 equals 0. And I'm just going to rearrange that to this. I would expect this to factorize, and I'm going to factorize in terms of cos x. So it's going to be 2 cos x and cos x to get that 2 cos squared x. Then I'm going to need a 1 and a 1 here if it's going to factorize, a plus here to give me 2 cos x, and a minus here to give me minus cos x. That will give me plus cos x overall. So cos x will equal a half or minus 1. For minus 1, we'll get that x is equal to pi. And then for half, I always remember it's cos 30 degrees is root 3 over 2, cos 60 is a half. That's going to be cos pi over 3. So x is going to equal pi over 3. That will give me this result here. But by symmetry, I can do 2 pi minus pi over 3. 2 pi is 6 pi over 3, so it's going to be 5 pi over 3. So those are all my solutions. I could write them all out. I'm just going to put a box around them. That's good enough. A more awkward second question, because we got some inverse causes going on. Okay, it looks like this is going to be a single value of x. Well, I'm going to write it as inverse cos. Now this is a bit awkward. How do we deal with this? Well, remember we could do the same thing to both sides, and to get rid of inverse cos, we're going to need to actually take cos of both sides. But you can't just do a cos to this and cos to this. That's not how it works. It's a bit like when you square root. If you square root a plus b, it's not the same as the square root of a plus the square root of b. By the way, cos of pi over 2 is 0. So I'm going to use addition formulae. Treat this as a and this is b. That's how we find cos of two things added together. Cos a plus b is equal to cos a cos b minus sine a sine b. Therefore, I can just replace, I can put that into here, so it's going to be cos of inverse cos of x times cos of inverse cos of 2x minus sine inverse cos of x times sine inverse cos of 2x equals 0. You might be thinking that looks worse. What are you on about? But we can simplify this quite a lot. Cos of inverse cos will just like they will cancel out, so we'll just get x, and the same over here. We'll get 2x. That's an all right bit. Okay, now to get I can't I can't cancel these out. I've got a sine and an inverse cos, but what I can do is something a little bit sneaky. I can use the fact, well, sine squared plus cos squared is 1, and that means sine squared is 1 minus cos squared. It might not seem very nice, but sine is therefore the square root of 1 minus cos squared. So I can write that this is going to be 1 minus cos squared inverse cos square rooted and times that by 1 minus cos squared inverse cos of 2x all square rooted. And remember, this equals 0. So all I've done is replaced sine by 1 minus cos squared, but I'm now finding cos squared of inverse cos. That's why this is actually a good idea. So 2x squared minus square root of 1 minus. Now remember, when we have cos squared, we actually find cos first and then we square it. So if you've got cos squared 30, you find cos of 30 and then you square it. You're not squaring 30, or you're not squaring inverse cos. So I find cos of inverse cos, which is just x, and then I square it. And I do the same here. I find cos of inverse cos 2x, which is 2x, and then I square that. And I've managed to get rid of all the trig. So what can we do here? I can write 2x squared. I've got a square root at the moment. That's not great, but I can add it. I can add this onto both sides. And actually, when you have a square root times a square root, you can just put it as a single square root. Just make sure you put brackets around both these terms. And we can square now. So it's going to be 4x to the 4 equals 1 minus x squared times 1 minus 4x squared. Now we have squared, so we just need to be careful about spurious solutions. Whenever you square an equation, it's just something that should be going through your mind. Extra solutions that don't actually exist. I have explained this in other videos. I'm not going to go into it now. We'll see if there are any, because we've still got quite a bit to do. So 4x to the 4. Right, expand this out. So it's going to be 1 minus 5x squared plus 4x to the 4. Oh, that's handy. These simply cancel. So I've got 5x squared equals 1. X squared equals 1/5. X equals plus or minus root 1/5. But okay, but we have the x is greater or equal to 0, so we can reject the negative. Now, I kind of think we don't even need to check this because we know that there is a solution. So it's not that this is going to be a spurious one. Sometimes you get it, but I think both of these would actually be okay because when we squared it, yeah, it wouldn't have had any effect. I think all right in this case. I'm not going to talk any more about that. That is the final answer. Okay, good job.